Cool. So I'm going to show the process I go through for updating my SmoothFlite, and this goes for the SmoothFlite 16 that you can see here, as well as any of the other SmoothFlite units. So for this, you're going to need your SmoothFlite, you're going to need your screen, and you're going to need this update cable. This is the AR update cable. It does not come with any of the SmoothFlite units, so you can purchase that separately. It is available obviously from the Baja RC website, but as well as from other places. Aeropanda sells it, I believe, Pacific RC Jets, etc. So that's what you'll need. The first step is getting a Windows computer that has internet connection, and we're gonna go look for the Baja RC AR updater. So if you just okay, so the first step is to connect the USB end of your cable into a USB port on the computer. And then once that's done, we're gonna plug the USB port, the other end of that cable, into the port that says display, plug that in, and then we're gonna start our utility, and it should automatically pick up that we have a SmoothFlite, and you can see that there. So it has picked up that we have a SmoothFlite unit, and we're gonna say yes. We don't need a battery because we're not connected to any servos. And it has picked up that we are in need of an update. So we're gonna update from 6.35 to 6.55. We're gonna say proceed, yes. And you let that take care of the update process, and I'll come back once that's done. Okay, so once that's done, you'll get a message on your screen asking you to unplug and power cycle. In this case, the update was successful. Say okay, and we're done. So at this point, your SmoothFlite unit has the latest firmware on there. So the next thing after that is going to be upgrading our screen. And so to do that, we'll just unplug this guy. And for the screen, this AR adapter cable comes with a spot for it. So right in here, we're gonna go ahead and plug the screen. So this is your screen. It comes with this cable that gets plugged into this unit. And then we repeat the process again. So we go to AR updater. It'll pick up that there's a screen, and you can see it's going to ask to flash the smart screen, and we say yes, and let it go through the process. And what you're looking to see is that your smart screen will go into a bootloader mode kind of thing. So this takes a little bit longer to update, and we'll just sit here and wait until that's done. So the smart screen is done, and you can see that you get a prompt that asks you to click OK, disconnect, and update, and you're done. So at this point, you have your SmoothFlite smart screen updated, and you have your SmoothFlite actual unit updated. So we're going to install it in the plane, and next thing is going through the setup for the F-15. Alright, so I've got my SmoothFlite 16 mounted on the jet. And the first thing we're going to do is get a receiver, and I'm going to be using the FreeSky TDMX. We're going to get this bound to a radio, and then we're going to install it into the R1 port. So the SmoothFlite 16, and I believe other SmoothFlite units, will take 2 receivers and 1 telemetry input. So in my case, I'm going to be using 2 TDMXs, which are FreeSky. And so that'll go into port R1, and then I'll go through the process of setting up your receiver protocol and then eventually programming the servos. So I have bound my receiver, and you can see that's in here, and that's plugged in to my SmoothFlite on port R1. I also, just for convenience's sake, bought the this remote switch. And the reason I like this is because I can turn the SmoothFlite unit on and off using a key fob, which is nice. So for instance, when I wanted to bind the receiver, I can just plug it into this port and use this to turn on and off, hold my button and bind. So it allows me to provide power to things and just have this to turn it on and off, which is nice, instead of having to unplug a battery. So what you'll notice here is if I look at my SmoothFlite screen, I have only one battery plugged in, which is this guy, and you can see that that's showing up as 8.3 volts, which is already nice. So what I'm gonna do is, using my finger, select the protocol that will tell the SmoothFlite that I want to use it with a FrSky receiver. So to do that, we go tap in the center of the screen, and we want to go into System. And once we're in System, you have your receiver protocol. We're going to select that, and in here we want to look for FrSky Export, and that's this option right here. That's what we're using, and you will change this to match whatever system you're using. So FrSky Export, we're going to select that, and you'll notice right here that it says that you need to disconnect servos, and it's going to reset all settings on the SmoothFlite. Not ideal, but then again, you know, this is how it works. Say you wanted to move from Spectrum to FrSky, it will do this process even though it's sitting in the same plane. So back up all your settings, and by backup I mean write them down, because there's no way as of the publishing of this video to get a cable or SD card and electronically back up those settings. So you're gonna have to do that manually. I believe AR is working on a way to get us backup capability. So we're gonna say yes, and you can see that it's initializing data, and then once that comes back, we're gonna see that it's gonna boot with the FrSky logo. You can see that right there. And now we're back in SmoothFlite, and we want to check. So my receiver right here, I'm gonna zoom out. Actually, I could just bring it in frame. So my receiver is blinking blue, and I know it's bound. My radio is off to the side here, and so what I'm gonna do is go into the monitor screen here, and you can see that SmoothFlite auto assigns certain channels. So you can see that if I move my elevator stick, my rudder stick, we have certain channels moving. So it comes with a pre-programmed channel sequence for all your channels. So what I like to do is completely erase that and install whatever channel mapping I want, matching that with my radio. So to clear up my screen, I'm gonna go to return, and I'm gonna go into IO routing, and here you can see anything that's in gray has been assigned. What's in green is what maps to your transmitter channel. So your transmitter channel is 1, and what this says is channel 1 is gonna control output 1 on the SmoothFlite on box, so on this box. So channel 1 on your transmitter, whatever you've set that to, is gonna move the servo that's on the port SmoothFlite port 1. So what I'm going to do is, because I want to change completely what this mapping is to whatever I want it to be, which is one of the great features of SmoothFlite, I'm just going to go and, using my finger or some item, I'm just going to unclick that, and you see that it turns blue, and that means that that channel has now been unassigned. I'm going to say save, and I'm going to go do that. So I'm going to go to channel 2, and you can see channel 2 is matched to port 2. I'm going to unclick that. I'm going to go to channel 3 is matched to port 3. I'm going to unclick that. I'm going to 4. I'm going to unclick that. I'm going to go to 5. Nothing is assigned. 6. I'm going to unclick that. And now you can see that all my channels on the SmoothFlite are blue. That means they're completely unassigned. So we're going to save that. Okay, and now when we go to our monitor, you can see that all of our channels are now blue instead of green. Blue means these guys are unassigned, so you can move your rudder, whatnot. It's the receiver is receiving that, passing that information onto the SmoothFlite, but since nothing is mapped, all of these are green. And you can also confirm that because when you click on that channel, you can see that receiver channel 1 and the assigned smart bus outputs, or the SmoothFlite outputs, there's nothing there. So now we have a blank slate, and we can now start assigning whatever channels we want onto the SmoothFlite. So the only requirement on SmoothFlite, and I'll mention this, is all of that tailoron mixing, blah, 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 all that happens on the SmoothFlite unit itself. And so the only thing that you need to set up on your radio is a regular channel. So single throttle, single elevator, single rudder. You can use dual if you want to assign a nose channel to a separate, but you can also do that mixing on the board itself. And the only thing that I recommend you use for 2 channels is the aileron. So SmoothFlite will by default expect that you have 2 aileron channels coming in on your receiver. And the reason for that is because once you have that set up, you can use crow or flaperons or full span flaps. All of that becomes really easy. You can also just use a single aileron and a single channel, which is fine, but you'll have to go into the SmoothFlite and let it know that there are, instead of 2 aileron channels, just 1. But I just recommend you set it up with dual aileron and everything else can be a single channel. All right, so this is something I'd like to address, which is the fact that I earlier said that only the aileron should have 2 channels, and yet in my mixer I'm using 2 things that have 2 channels. So you can see the ailerons have channel 1 and 5, and the flaps have channel 7 and 8. Is that there's no reason for these guys, for the flaps, to have 2 channels. I could have just as easily picked 1, because the SmoothFlite will allow me to mix those 2 servos into 1 channel. So I'm about to start plugging in my servos, and so the state of the world is I have my SmoothFlite battery plugged in, I have my remote switch plugged in, and that's that right here, and I have my SmoothFlite screen, that's this guy, plugged in. What I'm going to start with is setting up the tail surfaces. And so on my radio, the way that I chose to assign my channels is this way. So you can see that we have ailerons taking up channels 1 and 5, elevators taking up channel 2, throttles taking up channel 3, rudders taking up channel 4, flaps are going to be channel 7 and 8, the gear is going to be channel 6, the brake is going to be channel 9, SF master, I'll explain what that is, that's going to be channel 10, air brake is going to be 11, and then steer trim is going to be channel 12. And so we're going to use all of those in that order. And so we're going to map these channels onto the various ports on this unit that we want. So with that, let's go start plugging in. So I'm going to start with the way I like to wire my SmoothFlite is the channels that tend to be here will be from the back of the plane, and then I'll just move forward that way. So these 2 I'll assign to the 2 stabilators, and then the 2 rudders, and then the ailerons, and then the flap, and so on and so forth that way. And that keeps the symmetry. You have all your surfaces that are going to the right side of the plane will be on this side, and all the surfaces and controls that are going to the left side of the plane will be on the left side of the SmoothFlite. Grab my servo lead, and you can see I've labeled them with the heat shrink. So the first one is going to be the elevator left, and we're going to plug that into S01, and you just heard the surface move. And then to program it, all we're going to do is grab our screen, we're going to touch the center here, and we're going to go to IO routing. We want channel 2. I just showed that previously on my radio. So my radio is going to send channel 2 as the elevator channel. So we're going to set channel 2 to control output 1 and output 9, so that both of the stabilators go into that. We will eventually change this because we want to use tailerons, but that's a 2-minute process which we'll go over next. So I can now plug in my second stabilator onto port S09. I'll do that, and then we'll test it and show you how that works. So my right stabilator is plugged in to port 9. My left stabilator is plugged in to port 1. If we move the our elevator stick up, you can see that they're not quite moving in the right direction. So up elevator, you can see that one of them is backwards. And so that's easy to fix on the on our SmoothFlite, the servo that's connected to channel 1 on the SmoothFlite unit, so the left stabulator needs to be reversed. So all we do is we can go into monitor and we see we only have channel 2 from our receiver program. So if we click on that, we'll see our 2 channels corresponding to 1, which is the left stabulator, and 9, which is the right stabulator. We want to reverse 1, so we touch on 1 and we say servo direction reversed, and that's it. Hit return, 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 and we're done. And so now I'm going to pan the camera around. If we now look at our stabilators, our up elevator is up on both, our down elevator is down on both, and that's it. So we're not going to worry about aileron just yet. We're going to set up the entire plane and repeat this setup routine for all the servos, and then we're going to come and worry about the aileron. So I have set up all my servos right now, just in a normal way. So we have elevator, you can see that. We have ailerons, we have flaps, and we have rudders, and we also have gear. So this right here is the basic setup. The next important thing before we even go through the setup on the SmoothFlite, which is the fact that, as I just showed, the ailerons are channels 1 and 5. And so what I need to do is go into the SmoothFlite menu here. Let's zoom in closer. So in the SmoothFlite menu, we need to go to channel assign, and we need to make sure that these are set correctly. So in my case, aileron was channel 1 and 5, and you can see aileron channel 1 is the radio's channel 1, and aileron channel 2 is the radio's channel 5, which is exactly what my mix had set up. And then elevator is channel 2 on my radio, and rudder is channel 4 on my radio. The TX switch, which is set to 10, we'll go through that. We'll set that up during the wizard, but I just have it as 10, and this is so. Setting up the gyro is fairly easy. We'll click in the middle here, we'll go to SmoothFlite, and we'll go through the wizard. And a couple of questions you have to answer. We have a turbine, and I put 13 kilograms. That's the empty weight of the aircraft. Hit next, and then we go through a channel assign. And now here is where that SmoothFlite master comes into play. Remember that channel 10 right there, which is connected to switch G. So I'm just gonna flip the channel that's assigned to channel 10, and you can see that switch toggle the correct channel. We're gonna select next, and then at this point we're gonna enter the page that allows us to set our maximum throws. So here what I want to do is move my elevator to the max position, and you can see that as I do that, those numbers change. Then I want to move my aileron to the max position, and you can see what those numbers do. And the reason that you do this is so the SmoothFlite knows how far that surface should move. In my case, I've actually gone through and, based on Baja Hobby's manual, set the throws to be roughly what I expect them to be, and that's why these numbers are not going for full deflection. And then I do the same for my rudder here, and you can see what that deflection is. And once I have that, the next thing to do is just hit capture, and now the SmoothFlite knows what all these numbers are, what the maximum throws should be. We go to next. We want SmoothFlite on all the surfaces on this radio, on this model, I'm sorry. And here's where you can select which ones if you don't want it on the rudder, you just unclick that. And now you no longer have SmoothFlite on the rudder, but I want it on all of them. So I'm gonna say next. The mounting is standard, upright, front to back. Next. And then here I select sports mode. SmoothFlite smooth rolls here is kind of slow. So this would be cool if you have a really big model that, say, you want it to move very slowly and lifelike. But what I prefer is sport mode, because when the stick is in the center, you get that locked in feel. And then as you start to move your stick, so your aileron, your rudder, and your elevator away from center, then the gyro sort of starts to relax it, and the plane can actually roll or pitch as you want it to. So you get that locked in feeling when you're not moving the sticks, and that dynamic response as you move away from center. So that's what I'm going to select here. And then we're done. And then the next step is now to actually check that the control surfaces are actually moving the right way, the way we expect them to. All right, so the thing I want to explain here is how to check that your control surfaces are moving the right way when the gyro applies the correction to it. So the way I like to think about this is one of two ways. One is you can think that if you move the tail of the aircraft downwards, in other words, the nose is pitching up, you want the gyro to correct for that. And that would mean that the gyro would have to apply down elevator to compensate for that. A much easier way to think about it is that when you move the aircraft, whichever surface moves, or whichever area of the aircraft moves, the control surface that is associated with that area should lead that movement. What I mean is, if I lift the nose up, the tail of the aircraft goes down. If I'm looking at the elevators, what I should see is that the back of the elevator should point downwards. So it should lead that movement. And I'm going to show you exactly what I'm talking about. The elevators. And what I'm going to do is I'm going to lift the nose. So what do I expect to happen? So the first thing I expect to happen when I lift the nose is that this area is going to move downwards. What that means is if the elevator or stabilators are supposed to lead that movement, when I do the initial jolt, I expect to see these stabilators actually move in that direction. And what you'll notice is that if they move in that direction, they are actually applying down elevator. So that would lead the nose to actually come down. So essentially, if I lift the nose, the tail goes down, you expect that the elevator is also going to move down in the initial phase. So let's check that real quick. Flipped my SmoothFlite master switch 10 to the high gain position so that I can actually see the movement, and I'll show you how those gains can be adjusted. So I lift the nose, the tail goes down, the stabilators should lead that movement. So let's make sure that that's the case. So in this case, I'm going to lift the nose, and you see that the initial movement is for the elevators to actually lead that movement. And as soon as I let go, the nose is falling down. You expect that the tail is coming up, and so the elevators or the stabilators should actually lead that movement as well. So the initial jolt, where the nose is coming up and the tail is dropping, causes the elevators to also lead that movement. So you can see that correction there. So we're going to check the ailerons next. So I'm going to apply a force here. I'm going to lift this part of the wing up. What I expect is the aileron should deflect so as to lead that movement. In other words, this part of the wing goes up, the aileron should initially go up. So let's check that. And you see that that's the case. So right as I lift it, the aileron's first correction is to go up, which means that if our airplane is rolling clockwise, the aileron acts to counter that and cause the aircraft to roll the opposite rudder. And what I'm going to do is I'm going to kick the back end of the plane in one direction, and then again what you expect to see is that the rudder should lead that movement. So if I pick up the aircraft and swing the tail towards that direction, you expect that the initial movement of this rudder is going to be point that way. So let's check that. Here we go. Watch that rudder. So as you saw there, when the tail of the aircraft moves that way, the initial reaction of the rudders is to move that way, which means if the nose is moving sort of towards the left, the rudder will act to correct that, and that's what we're looking for. So now comes the question, well, in order for someone to do this check, you need to have the gains actually set pretty high so that you can actually see what that movement looks like. How do we do that? Well, that's also, as you might have guessed, pretty easy. So if we tap in the center of the screen, we go to SmoothFlite, and you can see right here you have all of the surfaces that can be gyro corrected. So we want to go to elevator, and you can see what these stock gains are. And what this page is showing is elevator is actually coming through channel 2 on our radio. The high gain is set to 40, the low gain is set to 20, high offset set to 35, low offset is set to 70. And then you can see that we've selected SmoothFlite as active and we've selected auto gain. Now, what are these parameters? Number one, high gain is what gain is going to be applied to the control surface when your SF master switch is in the high position. Low gain is what's going to be applied when your SF master switch is in the low position. And those are only going to be applied if the SmoothFlite is selected as being active. So if you uncheck this blue box here, that disables SmoothFlite. So that surface, in this case the elevator, is not going to get any gyro correction. Auto gain is a feature of SmoothFlite that makes sure that if you start to see oscillations, or if the aircraft starts to see oscillations because you've set, say, your high gain very high, what that's going to do is that it's going to automatically dial down the gain to reduce those vibrations to a very manageable oscillation. So you can imagine that you wouldn't get a situation where your aircraft goes out of control, because SmoothFlite will see that and catch it and quickly dial down that gain. So that is one of the really important features of SmoothFlite. So getting back to the original question is, if you want to actually see the gains work, what I do when I'm setting up the surface is I'll go to the high gain here and I'll just dial this up. So there's a plus plus sign, minus minus here, and I'll just dial that up really nicely high, so to like 70. And now if I put my SF master switch in the high position with the high gain for the elevator set to 70, I can actually see really well what that surface is doing, to check that it is correcting in the right manner. And then once I'm done, obviously, I'm gonna go select that. So if you unclick that, you see that that is no longer highlighted. So I'm gonna select that and then bring it back down to the stock number, which is 40. And we're done. I'm not quite sure what high offset and low offset do. It's explained in the manual. Maybe I'll do some more research and report that back at a later time. So that's pretty much how you go ahead and check that. Now, there's an invert here, and that's self-explanatory. So if you moved the aircraft and the control surface did the opposite, well, you just check that button and then you hit return. So once you hit return here, those settings are saved to the SmoothFlite and you're done. And so that's pretty much how you set up, reverse the gyro, check that it's moving in the right direction, and so on and so forth. So at this point, we've checked that our gyro is correcting correctly. We've set up our surfaces, and the next thing I'll show is how to do trims for the aircraft in general using the SmoothFlite. Okay, so say we want to trim this aileron servo right here. There's two ways to do that. We can do the trim in our radio, or we can do the trim on the SmoothFlite. I want to do the trim on the SmoothFlite, and that's just really a preference. If you prefer to do it in the radio, I think you can do it, but I think the recommendation is to do it on the SmoothFlite. That way you keep all the trim settings and all the mixing settings as close to the control surface actuator as possible. So how do we do that? Surface, you just go to the channel or the output channel on the SmoothFlite that's actually controlling that servo. The quickest way, or the way I like to do it, is go through the monitor. And in my case, I know that channel 1 is the aileron, so I'm going to click on that, and you can see that that channel 1 on my radio is assigned to channel 3 on the smart bus, or the AR. So if I click that, here you can see your sub-trim, your servo direction, and your 15-point servo match. So if I want to trim the servo, I click on sub-trim and servo match. And basically, I click on the sub-trim, and you just hit the plus or the minus or whatever, and that surface is going to actually trim itself up or down. And so you trim that. In this case, I entered a trim of -3, and that got my control surface pretty level. And that's it, and you're done. If you need to reverse the servo, you hit servo direction, that will reverse the servo, and then don't forget to hit return. And once you hit return, all those settings are saved, and you're done trimming the surface or the servo and reversing that channel as well. Finally, what I think I'm going to cover in this video is just a quick mention of all the other features that are on this. So if you go to monitor, as we were just there, so for the aileron, for instance, and we select channel 3, there's this thing called 15-point servo match. And that's a pretty amazing feature, because if you have 2 or 3 servos ganged up for a particular control surface and you need them perfectly synchronized, then this is the menu that you would select. And then you can see that that allows you to change up to 15 points. So this is a servo minimum, this is a servo maximum, and you can adjust what the PPM values for that position are. And if you do this for all the servos, you can get them pretty closely matched in terms of throw, and that allows you to synchronize the servos really well. So this is one of the reasons I really like this system. The other thing is that there's other advanced features here. So for example, you can go and apply an elevon mix. You can apply a crow and flaperons mix. And this is really important because that's why you want the ailerons separate. Because the ailerons, if you apply crow or flaperons, they're going to need to respond to 2 channels from your radio, the aileron channel as well as the flap channel. And this unit allows you to do all of that mixing in here. It allows you to do dual rudder brakes. It allows you to do steer switching, which is when the gear's up, you can use this unit to shut off any steering. You can do V-tail mixing. You can do vector switching. There's all sorts of things you can do with the SmoothFlite. And that's one of the reasons why it is one of my favorite systems to use. All right, so my initial setup is complete. I have my gears working. We just went through the SmoothFlite setup. That's working. I have my control surfaces all working. Flaps so far working. And so what's left at this point is set up our ailerons.